I've had several questions about the assignment, and a lot of people can get the graph, but they're having trouble writing the equation for it. So I thought I'd go over a couple of these examples. Okay, so the first one graph here I have. If you're looking at it, it's just it's a sine wave. There are some stretches, some movement, some phase shifts. First thing I'm going to notice is it's not centered at 0. It's up 3. Okay, so my midline is up 3. Also, it doesn't just go up 1 and down 1. It goes up 2 and down 2. Okay, so when I'm writing this function, it will look like f at x equals, well, first I'm going to take into account the stretch. Okay, so it's going to be, it doesn't go up 1, it's going up 2, so it's a vertical stretch by a factor of 2, sine, bracket, I'm going to write this up here, I'm running out of room here, okay, sorry, f at x equals 2 sine, bracket, x, and now we're looking at where your normal sine function starts. We know our sine function starts at the middle line, and it goes up, and it does this. So my sine function starts right here. Okay, so I now have, remember in the brackets, it's like opposite land, x minus 180, because it's horizontally shifted 180 units to the right, so we represent that by negative 180 there, end bracket, and of course my middle line, well, it's not at 0, it's up 3, so that's going to be represented like this, plus 3. Okay, so that would be the equation for that blue line there. However, some of you might see it different. Some of you might see this. Well, I have f at x. It starts at the normal spot, but it goes down. So there's still a stretch of 2, but some people may see it as a reflection in the x-axis. Therefore, I'm going to put a negative 2 there. Sine x, and since it starts at 0, there is no horizontal shift here. It was just reflected, plus 3. Okay, and if you will go on Desmos and graph both of those things, make sure you're in degree mode. You'll see that they are the exact same equation. Okay, in fact, there's infinite ways to write this equation because this is a continuous, the continuous wave. Let's go down to the next one here. So first thing noticed, always where's your center line is. Okay, so my center line here is at 5, so that's going to come into play. It looks like I go up 2 units on the graph. However, if you look, every unit is about 5. So therefore, I'm going up 10 and down 10. Okay, so I have a midline at 5. So if I write this out, I'm going to have f at x equals, well, my midline is that line at the end. Okay, there's my midline. So let's just put a plus 5 there. That's where it's centered. Okay, my amplitude is up 10. So let's put that at the beginning. Up 10. Of course, I have the sine function, bracket, and where does my function start? Well, I know that it starts the midline, and sine always starts up unless there's a reflection. I'm not really looking at reflection right now. So therefore, I'm going to say it starts here at negative 90. So that is a horizontal shift 90 units to the left. Therefore, I'm going to represent it by a x plus 90. Okay, that's one way. Someone else may see the same thing, but maybe they see it starting there. So f at x equals, I still have my 10, and I still have my plus 5. Those don't change. Sine of, and let's say they start there and it goes down, so they're going to represent that by negative 10, and it's x, because it's to the right 90, x minus 90. Okay? And then some people may not graph it on the negative side, so as they follow along, they feel the sine wave starts there. That's absolutely fine. That one, f at x, I still have my 10, I have my plus 5, I have my sine to start, and then I'm going to get a x, and it's moved to the right 270 units before it starts. Sorry, I messed up the graph here. But it's moved to the right 270 units, so I represent that by a negative 270. All of these are correct for writing this one orange sine function here. Okay, feel free, go into Desmos, just make sure that you are in degree mode. It's in the little toolbar in the top right corner. in degree mode when you graph them, and you'll see that all these graphs are the same. Hope this helps.